Hey, algebra students. Today we are finally going to finish 11.2. Um, in this part, we are going to really focus on not just simplifying one radical expression, but performing some operations with radical expressions and then making sure that our answer is in simplest form. So I want to remind you of our three conditions. Um, I know that you're familiar with them. I'm sure you have written them down in your notebook. But these are just things we need to keep in mind after we simplify or after we do the expression or the operations with the expression. These conditions still have to be met for our answer. So, the first thing we're going to do is we're going to talk about adding and subtracting radicals. So, when you add and subtract, I want you to really think of this as if the radicals are variables because you can add or you can subtract terms that have the same radicand, same number under that radical symbol. So again, think of it as variables. If they have the same variable, you can add them together, like terms. If they're like terms, you can add or subtract them. So in this expression, notice that the 2 radical 5 and the 6 radical 5 have the same number under the radicand. This would almost be like thinking 2x minus y plus 6x. We know that since the x's are the same, we can add them, but because this one is different, we can't. Okay? So we're going to add the radical 5's together, and we're going to think of this number as the coefficient. So 2 radical 5 plus 6 radical 5. 2 plus 6 is 8 radical 5. The radical 5 does not add with this radical 5. Just like when we had 2x minus y plus 6x. We did 2 plus 6. This would give us 8x. We would not add the x's together right here. So the radicand stays the same. Very important that you realize the radicand stays the same. 2 radical 5 plus 6 radical 5 becomes 8 radical 5. And then we just drop down the one that we didn't use, minus radical 7. And because these are different, we can't do this subtraction. This would be our simplified expression. Here's another expression. Right off the bat, you can tell that none of the radicands are the same. However, we need to make sure that our conditions for simplest form of radical expressions are met. So we need to make sure there are no perfect squares under the radicands. So each one we need to think of, can I divide it by a perfect square? Radical 6, no. There are no perfect squares other than 1 that I can divide 6 by. Radical 12, yes, I can simplify that. Radical 24, yes, I can simplify that. So before we do the subtraction and the addition, we're actually going to simplify, and let's just see what happens. So 7 radical 6 minus 2 radical 12, I'm going to break that up. I know I can divide it by 4, which is a perfect square, so I'm going to break it up into radical 4 times radical 3. Plus radical 24, I'm going to simplify that as well. I can divide that by 4, so I'm going to break radical 24 up into radical 4 times radical 6. And I'm going to rewrite after simplifying all that. So 7 radical 6 stays the same like we said. Radical 4 is 2. So this is minus 2 times radical 3 plus radical 4 again is 2 times this radical 6. So let's just clean this up a little bit. 7 radical 6. 2 times 2 is 4. It's negative 2 times 2, so negative 4 times radical 3 plus 2 radical 6. And now all the radicals are simplified. Now let's look for like terms. And you should be able to see we have like terms right here with radical 6's. So I'm going to do 7 radical 6 plus 2 radical 6 because it's positive. So 7 radical 6 plus 2 radical 6 is 9 radical 6. Again, don't add the 6's. And then just drop down the term that was not like them, minus 4 radical 3. And there's our simplified expression. The other thing we're going to talk about is multiplying radical expressions. I want you to think of this as just using distributive property or even FOIL when we get to things that look like binomials. And again, treat those radicals as variables if you need to, or think of them as variables. So on this one, we're just doing distributive property. Radical 5 multiplied by this expression in parentheses. We're just going to multiply everything in the parentheses by radical 5. So radical 5 times 4. The radical 5 is under the radicand. The 4 is not. So when we multiply those, we would just write the 4 outside and then the radical 5. Now, the minus sign tells us that this radical 20 is negative. So it's positive times negative, so we know that's going to be a negative. They're both radicals, so we can multiply them together and put them under one radical symbol. 5 times 20 would be 100. So radical 5 times radical 20 is radical 100, and it's negative. Now we can simplify. So for radical 5, I can't do anything to the radical 5. Doesn't have any perfect square factors. So just copy it down. Minus radical 100. 100 is a perfect square. Radical 100 is 10. And then I would look to see if I can combine any like terms, add, subtract things together. All I have is subtraction here, but these are not like terms. This has a radical 5. This one does not. This would be my simplified expression. Here's what I'm talking about if you like FOIL. You can FOIL, meaning multiply the first ones together, multiply the outside ones together, this one and this one, multiply the inside ones together, multiply the last one in each grouping together, or you can just think of it as distributive property. So I'm going to go one thing at a time here. Radical 7 times radical 7. I'm just going to write this out. I'm not even going to simplify it yet. Radical 7 times radical 7. I'm going to show all the multiplication. Then we have radical 7 times negative 3 radical 2. So negative 3 radical 2, it's being multiplied by radical 7. Then I would do this radical 2 times everything in the parentheses. It's positive, so plus radical 2 times radical 7. And then I'm going to finish it off by doing radical 2 times negative 3 radical 2. Radical 2 times negative 3 radical 2. We know that's going to be negative. Let's just write out the multiplication. Negative 3 radical 2 times radical 2. And now let's multiply. Let's clean some things up. Radical 7 times radical 7 is radical 49. When we multiply these, we can multiply the two numbers under the radical. Minus 3 times radical 14 plus multiply these two, radical 14 minus 3 times radical, that would be 4. 2 times 2 is 4. Now let's simplify even more. So this is a perfect square. That's 7. I don't believe we can simplify radical 14. No perfect square factors. So minus 3 radical 14 plus another radical 14. We have a perfect square right here. Square root of 4, that is 2. So it's just 3 times 2. Let me clean it up. 3 times 2 would be 6. And now we look for like terms. So we have whole numbers, 7, negative 6. So we can combine those. 7 minus 6 is 1. Copy everything else down. We have negative 3 radical 14 plus radical 14. If there's no number out here, remember it's like there's an invisible 1 right there. That's like 1 radical 14. They have the same number under the radical, so same radicands, so we can combine them. Negative 3 radical 14 plus 1 radical 14 would be negative 2 radical 14. And we cannot do the subtraction here. This does not have a radical 14. This would be our simplified expression. One more. So we are actually taking this expression and squaring it, which means we're multiplying it by itself. So I would recommend writing that out. And we're going to do the exact same thing we did in the last problem. If you need to think of FOIL, you can think of FOIL or distributive property with each one of these. I'm going to do this a little bit more efficiently. Instead of writing out what I'm multiplying, I'm going to kind of simplify as I go. So radical 5 times radical 5, that's radical 25. Radical 5 times this 3 radical 2. It's positive times positive, so it's going to be plus. The 3 is outside, the 5 and the 2 are inside, so that would be radical 10. Then I would multiply this 3 radical 2 times this set of parentheses. So positive 3 radical 2 times radical 5. Again, it's positive. The 3 is outside. Multiply the 2 and the 5 because they're both under the radical symbol. That would be radical 10. And then 3 radical 2 times 3 radical 2 is positive. 3 times 3 would be 9. Radical 2 times radical 2 would be radical 4. And now we simplify. Radical 25, that is 5. Plus 3 radical 10, just copy everything else down. I know I can also simplify radical 4. That's just 2, so that's 9 times 2. So again, we got some with whole numbers, some with radicands. 9 times 2 is 18. So let's add the whole numbers together. 5 and 18, that's 23. And hopefully you've already seen we have some like terms here, radical 10 plus radical 10. So 3 radical 10 plus 3 radical 10 is 6 radical 10. And there's our simplified expression. So kind of a review of everything we've done in section 11.2. All 3 conditions of simplifying expressions, but just adding on some operations with them as well, multiplying them together, adding, subtracting radicals. So I hope that helps you with today's assignment. Please let me know if you need some help through email. Hope you have a great day.